All right. You know, I feel like they're trying to send us a sign when the background is red, like danger, danger, atmospheric pollution and stratospheric ozone depletion. Oh no. All right. Okay. Let's get to work. So, first module here, what we're going to look at is we're going to talk about what some of those major air pollutants are and their sources in our atmosphere. So let's define what air pollution is. So first of all, it is definitely what we would consider a global system. Why do we consider that a global system? Is because it occurs everywhere, all around the world, and it can move from one place to another. All right, it's not defined within country boundaries. So air pollution can be chemicals. It can be microorganisms like dust mites. It could be particulate matter. It could be viruses and bacteria that are in the air. And so, any of those things that can possibly hurt not just humans, but other living organisms and ecosystems and buildings too, then that would be considered air pollution. Air pollution has lots of inputs and outputs. Let's talk about what those are. So, inputs are what makes them, like what are those chemicals? What are those bad things? The outputs could be how they affect certain things, and then they can be the consequences. Okay. All right. SO2. This one is very important. All right. So, sulfur dioxide is nasty stuff. It's a corrosive, gross gas. It comes from usually the combustion process from burning coal and oil. And SO2, they have scrubbers, they have ways to mediate it. And by law here in the United States, and most countries do try to limit the amount of SO2 that is pumped into the atmosphere. All depends on where you are in the world. But for humans, it is a respiratory irritant, which means that if you have asthma, it could really aggravate that. If you are prone to emphysema, other types of lung issues, then this is a really bad pollutant. Um, SO2 is also naturally released into the atmosphere during volcanic eruptions. And during volcanic eruptions, it can be quite a bit, can be emitted. Some, excuse me, I yawned. Some can be released during forest fires, but it's not that much. All right, the other big one that we're going to talk about are nitrogen oxides. Now, notice up here it says NO sub of X. The reason why that is it could be NO2 or it could be NO3. Nitrites or nitrates, those are different types of nitrogen oxides. Those of you in chemistry, you're like, yeah, that sounds familiar. Exactly. So, motor vehicles, anything that burns off of fossil fuels, they produce nitrogen oxides, or we'll call them NOx compounds. And again, they bother you if you are prone to lung issues. They are respiratory irritants. They also are important whenever it comes to looking at the amount of smog that builds up in a city or over an area in the sky. It's what we call an ozone precursor, which we will talk about. When it's in the atmosphere, what happens is the NOx compound will combine with hydrogen and form nitric acid. And if that nitric acid gets into or is like rained down upon on vegetation, it could have bad consequences. And then obviously, too, for aquatic life, because it will dissolve in the water. And NOx compounds can also they can also sometimes be released from like dropping like you'll sometimes see like air dropped like fertilizer planes. Okay, so those fertilizer planes do is they drop like a liquid version of fertilizer on plants, on crops. And those what those crop dusters do is when That's what they try to get down low above the plants and dump it. But some of it is going to evaporate back up into the atmosphere. And so it's bad. All right, so now we also have our carbon oxides. Now, carbon dioxide is the one that gets the most attention, but there's also carbon monoxide, which should get equally as amount of attention because it is the silent killer. Carbon monoxide is commonly found in the exhaust of, again, vehicles, and that was burned through using fossil fuels and other combustion processes. Carbon monoxide can build up in older homes inside if you have like the old school radiators and heating systems. That can be a problem. You cannot smell it. You cannot determine by any other, but unless you test for it, that it's present, but it can basically suffocate you in your sleep. So CO is a bad thing. Carbon dioxide, we also know is a bad thing. And we also know that it's released from burning fossil fuels. It is a huge major pollutant. And the rate of it is going up. You saw from that practice FRQ how it kind of the amount of carbon dioxide in the atmosphere over a long period of time has been traced through looking at things like tree rings and things like that. And they can help determine how it has increased because of cool techniques like that. All right, so those are some chemical pollutants. Now let's talk about what particulate matter is. Particulate matter is dust, smoke, stuff that gets blown into the airs. It's anything that is like a tiny, minuscule solid that gets flushed up into the air. So it could be ash from volcanoes. Whenever you burn your campfire, you smell like campfire. Well, and that smoke is releasing little particulate matter into the atmosphere. So things like that. Some particulate matter is natural, like the volcanoes, natural forest fires, things like that. But then it can also be anthropogenic, aka human caused, because we like to burn stuff, and we also like knock stuff up into the atmosphere through driving, things like that. All right, so here's some terms you need to know. Haze. Haze is just whenever you look out and the sky is not clear. It's kind of not cloudy, but it's got a almost sometimes like an orangey, not like this background, like an orangey kind of tint to it. It's definitely have particulate matter suspended in the air. There are photochemical oxidants. These react with sunlight, and what they do is these photochemical oxidants is as soon as sunlight hits them, that sunlight makes it undergo a reaction, and this is sometimes how nitrogen oxides form. Ozone is O3. So oxygen, the molecule, O2 is O2. Ozone is O3. And so it's 3 oxygen atoms bound together in kind of an awkward format. So it's not super stable, not as stable as O2, but under some certain circumstances, it is definitely more stable. Smog comes from the word of smoke and fog, but it's not just fog. Really, what it is, it's kind of like you have that haze in the air, and smog can be caused by different things. One of those is photochemical smog. This is what we call brown smog. And this is what we have over the city. And we get it in San Antonio sometimes when it's hot in the summer. And you go outside and you see that kind of hazy stuff kind of sitting over the downtown area. That is photochemical smog. Then we also have sulfurous smog. This is typically also commonly known as industrial smog. I've never really heard it gray smog, but okay. But this is caused more from the sulfur compounds than it is by some of the other oxidants that are out there. All right, so you need to know these as well. Lead. Why does lead get into the atmosphere, right? You're like, what the what? So lead gets into the atmospheres because we burn gasoline. And guess what? When you go put gas in your car, what is it called? Unleaded. That's right. Because they try to take as much of that lead out as they possibly can. Back in the day, before I was even born, they had leaded gasoline, and that lead would get into the atmosphere. Most regions around the world only sell unleaded gasoline, as far as I know. As far as I know. But lead is a heavy metal, and that heavy metal has big time consequences on the nervous system of not just us, but other organisms as well. All right, VOCs, volatile organic compounds. These bad boys are compounds that evaporate quickly. And that's why they're called volatile. That means that they just evaporate very quickly at room temperature. Gasoline, a lot of solvents like paint thinner, a lot of paints. Like whenever you paint the room, if you go buy paint, it might say low VOC on it. And what that means is they've tried to minimize the amount of additives and what it does, those VOCs, since they evaporate quickly, it makes your paint dry more quickly. But obviously, you don't necessarily want to breathe them in. Yeah. Other solvents would be things like fingernail polish remover. Right. So maybe that's kind of like, oh, okay. So that's what that is. Yes. And these two are precursors to creating ozone. All right. So we have primary and secondary pollutants. Primary are ones that it's like right straight out of the smokestack, the exhaust pipe, the volcano. It's the pollutants that are just immediately put into the air, right? They have not reacted. They're just there. Okay. Secondary pollutants are ones that have undergone some type of chemical reaction, and they have been oxidized or something like that, have bonded with hydrogen to form an acidic compound. And these are secondary pollutants. So this picture shows you some primary and secondary air pollutants. Primary pollutants, you can see there's a lot of the big heavy hitters out there are primary pollutants. And then if they react with the sunlight or with something else up in the atmosphere, especially at higher temperatures, then they can create secondary pollutants. Okay, so as I've kind of mentioned, air pollution can be naturally caused, but it can also be anthropogenic. Probably one of the biggest natural causes of air pollution is going to be from volcanoes. They can spew ash and cinders up way high up into the air, and that stuff can get into jet stream. It can circulate almost all the way around the world. It's pretty intense. Events such as lightning, it does create some slight ozone type products. Forest fires, photosynthesis. I mean, they all can create some kinds of emissions. So, I mean, when I say emissions, that just means that something is released. So, when I say photosynthesis, what does photosynthesis release? Oxygen. Yeah. Okay. Anthropogenic, that is all about us, baby. So that's what we drive. That's what we burn. That's what we make. Yeah. Yeah. That's us. So, talking about us a little bit more here. Emissions, again, just means what's released into the atmosphere. So, in the United States and other most developed countries, like you talk about the Paris Climate Agreement and all these kinds of things, which we just signed back into, we all monitor and regulate what we're allowed to put into the atmosphere. Okay. So it is monitored. Now, could it be done so more closely or to higher or more strict levels? Yeah, I'm going to leave that up to you to think if that's your opinion. But let's kind of get back on track here. So most of the common sources for this are going to be stuff like burning your trash, factory outputs, that kind of stuff, driving our cars, our big old diesel trucks, that kind of stuff. So we have the Clean Air Act, and what it does is it tries to establish specific standards to prevent like going above certain amounts of some of these noxious chemicals that get released into the environment. And they change. I mean, it all kind of depends as to who's president and what Congress has said and done and reenacted and passed and not passed and all this. So it changes. Not like every day, but 4 or 5 years. I mean, it does, it fluctuates. And then we also have the National Ambient Air Quality Standards. And that really specifies for each individual pollutant what, like you should not be pumping more than X of these NOx compounds out into the atmosphere. So, as you can see here, I don't remember what year this is from. I want to say this is from about 2018. So it's fairly recent. And this shows how you can tell that most of our carbon monoxide and nitrogen oxide emissions comes from our cars. Yep. Secondarily, for carbon monoxide would be burning fires. And then we also have, miscellaneous things down here. As for the nitrogen oxides, then it goes our vehicles again, power plants, and then kind of industrial processes, and then it kind of putters out. Now, anthropogenic emissions in terms of sulfur dioxide for us, that mostly comes from power plants. It's not really emitted so much by cars. Okay. It's just not. That's created by power plants and burning things like coal and natural gas. Then particulate matter. Particulate matter is what we were talking about, the haze, the smoke, right, from fires. Agriculture, guess what that would be? Pollen. Yeah. I know, right? Seeds, little dandelion seeds, things like that. But a lot of it's pollen. So whenever you count the pollen, yep. Dust, power plants, mobile, like that would be cars. That would be us, like knocking up the dirt, going down our backcountry roads. Miscellaneous, it can take a lot of different stuff into account. One of which just popped into my head and I just totally forgot it. What was it? Maybe I'll think about it. Fires, agriculture. Okay, I guess not. If I do think of it, I'll tell you. I promise. And then industrial processes. All right, so look at this. This is actually a good graph, right? Look at this, guys. Look, it's actually showing that we're getting better at something. And we're not just making things worse. Yay. Now, is it good enough? Is it? I don't know. I mean, just because it's what the national standards are doesn't mean that that is where they should be to curb climate change. Okay. There is talk about that. But as you can see from this graph, we are getting better. We are decreasing our usage of certain chemicals in the atmosphere, which is good. All right, I'm going to pause there.